Thank you very much for your introduction. So I will talk about our semiconductor startup, Reexen Technology. It was founded in 2018 by a Chinese ETH graduate. She founded the company in two crazy areas, Zurich, crazy for innovation, and China, crazy for business. And thanks to good partnerships with a number one equipment manufacturer, the company quickly grew in, especially in China, but is continuing to progress on the two sites. And we have now like 60 people working, most of them in R&D. And we are focusing on low power AI processors, IPs and ASICs for IoT and mobile applications. And we use different solutions for that, in-memory computing and an intelligent mixed signal chain. So let's see our mission. Why AI is interesting to be in the IoT is like, first of all, if you process your data locally, you will save a lot of energy rather than using a lot of RF bandwidth to transmit it to the cloud. This will also save on the cost. You will also get much faster. And finally, we saw a lot of privacy and security issues. If you process your data locally, you are securing your privacy and avoiding, for instance, a video stream or an audio stream of your life being leaked. You would rather prefer to just have your switch on the bulb command to be leaked if it is hacked. The question is not if it will be hacked, but when it will be hacked. So our first solution is an intelligent mixed signal sensing chain. So traditionally, in sensor chips, you have your sensor linked to analog front-end circuits, ADCs to convert the signal into the digital world, and some preprocessing that is engineer handmade, and then you add the AI layer to process it. Our first solutions was to combine that. Instead of making that handmade preprocessing and go to the AI, why not to just let the AI make its own preprocessing, and it will better know what features it needs to extract and how to process them to better take the decision. Second solutions that we have is in-memory computing. Traditional computing systems, they split the memory and the computations in two parts. Like it's normal if you have a big program and you store your lines of code somewhere, your data somewhere, and you access them some of the lines at one moment or at another moment in order to compute with them. But with AI, it's different. It's millions of data you have on memory and billions of computations you have to do with those data, always in a very regular way. So for that, what is the critical part is the bandwidth. So using computing in memory, it's a kind of new trend that came slowly. It's even more than GPU that is optimizing this kind of thing. Using memory in computing allows to really leverage that bandwidth issue and improve the efficiency of the computations. And now that our technology is maturing, what we are trying to do now is to build a more vertical approach and to bring our hardware closer to the software. Giving the chip to a customer is not the best solution. They often don't optimize enough their systems. They don't cross optimize with our hardware. Sorry. So in order to enable cross-level optimizations, we would like to bring our hardware closer to the software thanks to different platform and interface solutions. So one of the applications we are having, for instance, our ADA 100 chip is an audio chip combined with a conventional microphone. You get a smart microphone, and integrating them in an earphone, you get a smart earplug that can make noise cancelling, advanced functions, that can recognize your voice keywords, and it's all locally instead of being sent to the cloud. Another solutions with our more advanced chip that is making image and vision processing. coupled with different types of cameras. You could either track the eyes, the attentions of the user of the glasses, or track the gestures of the people in front of him. And finally, also coupled with motion sensors, accelerometers, you can have a full environmental awareness around the person. So our story is continuing. We have, so you see our two first chips came into mass production, and we are working on more advanced image and vision chips that will be for mobile applications as well as autonomous driving. And that's the end of my presentation.
Thank you for your presentation, Vincent.
Thank you.
Questions from the audience? Just one question then, very quickly. Where do you see the biggest challenges in the coming years for AI and for IoT?
But the processing is definitively a big issue, but I feel it's harder to bring the customer solutions to the hardware. You know, big guys, they are making microcontrollers, they are making very generic things, and there is not enough co-optimization, and it's very hard to do because it's time consuming. People want to throw the application as fast as possible, which goes against also security.
Okay. Thank you. Thank you for your contribution.
Thank you very much.